So what about this negative 11 pi over 4 thing? Okay, what about this? Do I want you to like answer it right now? I'd like you to kind of think about it. But maybe you say, yeah, I'm not really sure. I don't even know where to start. But just take a pause. I just want you to at least think about it. Where do you think is negative 11 pi over 4? Now, I did say we're going to learn how to do this period. But it is a good way to learn to kind of see if you already have an idea. And then you might find out, oh, I was right. Or maybe you have to change what you were thinking. By the way, as a lot of you do, have your calculator handy. It will come in handy for other things today. So if you haven't pulled it out yet, I would say have that as a tool. You'll use it beyond just this little problem. Did you get to the point that you at least realize that this is like a different type of size? Maybe some of you are saying it's like big. It's bigger than I expected. That's good. Good. I want you to have gotten to that point. Like, what are you going to do with that? If you're a little stuck, maybe hang in there and, we'll answer that here by the end of the period. What if we were able to convert this into degrees? What if with a snap of the fingers you were able to say how many degrees this was? Do you feel like you would know a little better where it was located? Okay, that's going to be the essence of today's lesson. We're going to convert. We're literally going to change these types of numbers into degrees, or vice versa. We're going to change degrees to radians. Okay, now the topic is converting, but the big idea is so we're converting so that you understand what this is. Okay, and right now, maybe you're saying, what's the answer? Like, I'm kind of purposely not telling you the answer. That way you have to stick around here. But maybe if we can convert this, you'll feel like that you know a little better where it is. When converting, there's a ratio. It's like the thing. It's the primary ratio. Maybe to give it a little more emphasis, it's the ratio. Now, the ratio we use for converting, and just switch to your notes so that you're able to follow along here. The ratio that we use for all converting is pi to 180. Pi is to 180. Now, I used a couple words here already. One of them is just the idea of a ratio. Remember, ratios kind of like compare things. In this case, they're saying that these two are equal. And if you're like, whoa, why? Why is pi equal to 180? What we're doing is we're appealing to yesterday's lesson, where you learned that if you go halfway around a circle, that's the same as pi. And we know that 180 is halfway around a circle. So it's always this. It's always this. Now, let me show you how to use it. You'll like this. This is actually kind of a nice, hey, if you follow these steps, it's going to work. Let's convert degrees to radians. Kind of put a little box on this, but let's convert degrees to radians. Now, what this means is I'm going to give you something in degrees, and we're going to switch it to radians. So how about 30 degrees? How about 30 degrees? Can we try to turn that into radians? Well, yes, we can, using this primary ratio. Now, the way to use this ratio is actually to set it equal to and create a proportion. So a proportion is when you start to put an equal sign with two ratios. So now what we need is another ratio. Well, notice that the numerator has the radians. That's what we're trying to find. So that would be your variable, x. And notice the denominator has your degrees. And of course, that's what we're given. So we're kind of going back a little bit to that, ratio math that you did some time ago, where we just say that these two fractions need to be equal. And of course, you solve for x. Now, I'm sure that you learned when you were doing proportions, in grade school and junior high, that you cross multiply. Right, you cross multiply. But the reason you're cross multiplying is because you're trying to isolate x. And so I would say to you that you realize that the only thing that really needs to disappear, that needs to move, is the 30. So I'm not really going to cross multiply. I'm just going to multiply. I'm going to multiply by 30 because now x is isolated. If you cross multiply, now you got 180 moving around, and we don't need to move 180. So you multiply both sides by 30, and all we need to understand is how to write this answer. Now, what I wrote on the board is correct. It's just not simplified. So I have 30 pi over 180, but we want to simplify it. Now, not into a decimal. I know we've used some decimals yesterday, but today, if we're going to convert this, we actually just want to keep it as a fraction, but reduce it. So we want to reduce 30 over 180. Okay, and what do you guys know about reducing? There's different ways to do it. You can divide by the same number. Some people look at this and say that it reduces by 30s. As if you reduce this down to its lowest terms, you're going to cross out the 30, get a 1, and you're going to reduce the 180 to be 6. So you reduce it by 30s. Now, look at how you write the answer, pi over 6. Pi over 6. I didn't change it to a decimal because in the math etiquette book, there's a math etiquette book that talks about certain ways to write answers in certain scenarios. When you're talking about radians, if you're able to give the answer with pi, you do that. So we leave the pi on the fraction. Hey, pi over 6. I'll say, does it look familiar? You say, I don't know. Should it? Well, yesterday, and I know we just started this yesterday, but yesterday we said that pi over 6 was 30 degrees. So I'm simply saying that this is definitely right because 30 degrees from yesterday is the same as pi over 6. Let's do one where you don't know the answer from yesterday. 265 degrees. 265 degrees. I would encourage you, why don't you try this? If you think you can follow the same thing I did, it'll work. You want to set up a ratio that turns into a proportion. Now, you guys are pretty normal. The main thing that, if I could say that either you're struggling with or maybe you're a little unsure, is just how to simplify this fraction. So, yes, nice job. X over 265. Yes, multiply by 265. Now, be careful. This is where, for a couple of you, how do you do that? How do you multiply by 265? To the numerator. It's 265 to the numerator. So we're not multiplying 180 and 265. We actually are trying to reduce 180 and 265. Now, to reduce these, you're just trying to find like that, what is it called? Like the greatest common factor. You're basically trying to find what a number that divides into those. Okay, remember some of your division rules. these numbers end in a 0 and a 5. They're definitely going to be divisible by 5. So maybe start by dividing by 5. It turns out that that's the greatest common factor because that's the only number that divides into both of these. So you divide by 5, you reduce by 5, okay? 265 reduced by 5 is 53. 180 reduced with a 5 is 36. You're not alone if you were a little stuck on that step. Those numbers were a little bit bigger, but you're trying to find the greatest number that can reduce or divide into those. Now look at how I wrote the answer, 53 pi over 36. A lot of times people are like, is that right? Because you've never seen that before. 53 pi over 36. I just want you to understand that that's just a number. It's the number, oh, I already have it up here. It's the number 4.6. Now, what does that mean? That's 4.6 radians. So 4.6 of these. Now, if you think about that a little bit, that's going to get you all the way to 265. Okay, because, well, 265 is about right there. And this is 4.7. So 4.7 is the whole way down at that 270, but I'm at 4.6. Just trying to help you understand that it makes sense. If we start thinking about it, it makes sense. Questions? Can we kind of be honest with each other? Why would you want to take degrees and turn into radians? Honestly, the answer to that is just to say that you can, okay? But it's not real practical because you're taking something you like and you're kind of turning into something that you maybe don't like. Why don't you just divide by 57.3? Now, 57.3 is a nice number that you could use. You could divide it. Okay, the only thing is that it's not as accurate. It's not as accurate as this. Okay, because 57.3 is just slightly estimated. This is sort of perfect. By the way, 57.3 is 180 divided by pi. If you want to randomly check that out, that's how we got that number. So, Evan? No, Giuseppe, sorry. They're definitely related, okay? I mean, it's like the same idea. It's just that the ratio is a little bit better. Let's do something that is practical. As I'm suggesting here, I'm admitting to that you might be like, why would I do this? Well, maybe the answer is so that we also understand how to go this way. This is the essence of today's lesson. To be able to go the other way. To be able to take something that's in radians and turn it into degrees. Now, I think you're going to say it's like the same thing we did over here. We just got to be careful with how we set up our proportion. Seven pi over 8. As I kind of said with the little challenge question, where is that? What is that? Okay, maybe if we turn into degrees, we'll know what it is, where it is. Okay, now to do it, it's still pi over 180. That's the good news. It's the same thing. Radians goes in the numerator. So now I fill in my 7 pi over 8 over, this time my unknown, over x. So degrees goes in the denominator. Let's work this first one out together. It's still just a proportion, but make sure you understand what you're trying to do. You're trying to solve for x. Now, algebra would say that since x is in the denominator, we want to move it up to the numerator. So, yeah, we're going to cross multiply. And this 180, we also want to move it up here so that we can basically eliminate the whole fraction. So we're going to straight up cross multiply. Take a look at what it looks like. It's pi x equaling 180 times 7 pi over 8. Now remember, you're trying to solve for x. This is like algebra. Honestly, there's something really nice here. It's this pi that's on both sides. Anytime you have something equivalent on both sides, it can divide out. So why wouldn't you? Okay, you should. You should divide out those pi's. Now look at what you're really going to punch into your calculator. 7/8 of 180. 7/8 of 180. Play along, make sure that you can do it. As you do it, realize that this is the degrees. This is the degrees. That's equivalent to our original radian. So 157 degrees, 157.5 degrees is equivalent to 7 pi over 8. You know, remember what I kind of said at the beginning here. Where is this? Well, the answer is, where's 157? You know where 157 is, but that's the same as 7 pi over 8. Okay, changing into degrees, pretty nice. Negative 2 pi over 3. Negative 2 pi over 3. You want to see if you can turn that into degrees? Justin, how did you set it up? What was your initial proportion? There's not too much that you can go wrong there. Just realize that radians is in the top, degrees is in the bottom. So negative 2 pi over 3 is in the top, x is in the bottom, since we're trying to turn it into degrees. Kara, what about starting to solve it? Can you maybe give us a solve step? Okay, pi times x. All right, so we got pi x equaling 180 times negative 2 pi over 3. Sort of simplifying, basically starting to finish that. Donovan.
So then you get rid of pi, and then that leaves you with x equals 180 times negative 2/3.
Good. Now, did you hear what Donovan said? You know, you got pi on both sides. Sometimes students say, well, is that always going to happen? Well, if they're on both sides, it happens. But there's a situation where if that pi is not on both sides, then you can't cancel it. So yes, you always cancel it if it's on both sides. I want to do one more problem with you here. And then this guy that was kind of it's been hanging out all period, you're starting to feel like you might have a way that you can do that. We're going to do that, but I want to make sure that you see this. It's just a little different. 4 radians to degrees. 4 radians to degrees. Now, I want to make sure you don't sort of assume or imply something that I didn't say. And I didn't say 4 pi. I didn't say 4 pi. It's just 4. Okay, now it's still radians to degrees, so I can still set up my proportion. I can still put 4 in the numerator. I honestly hope that you are saying, yeah, you're doing the same thing. Yep. But it's just 4 radians, not 4 pi. Now you can cross multiply. In fact, you should cross multiply. And you get pi x equaling 4 1/80s. So you have pi x equaling 4 1/80s. Now you can certainly multiply that. Maybe you are and you're getting 720. That's good. But here's the part I want you to focus on. I don't have a pi to cancel, so the only thing I can do is divide by pi. So when you divide by pi, well, 720 divided by 3, or 720 divided by pi, will give you your degrees. Now, the whole point behind this is to say that it makes sense. So 229.2, can we say that that makes sense? I want to go back to this 4. I kind of wonder if I didn't say anything, what would you have thought? But 4 is really referring to something that you saw in your homework and something that you've seen a couple times today. That is 4 radians, somewhere between 3 and 4.7. Well, if you think about the angle I just made there, that is definitely in the ballpark of 229. Okay, so it's supposed to start to make sense. You're supposed to say, yeah, they're the same. So where is negative 11 pi over 4? Now listen, I'm going to ask you to do this like a little exit ticket. So before you start scribbling in your notes, I'm going to give you a little scrap paper here. So you can start thinking about what you're going to do, but take this scratch paper. Now, what's an exit ticket? Well, in my book, I'm trying to get your attention a little more. I'm trying to say, hey, I want you to be able to do this. I want you to try to get it right. But I want you to know that it's not a quiz. It's not a quiz. So you can talk about it. In fact, a lot of students will work on this. But before you turn it in, maybe you'll have an interaction with someone, and you're allowed to do that. Okay, because maybe you find out that you made a mistake. I'd rather you fix it. Okay, so it's not a quiz. It's a little exit ticket. Your answer needs to show that you know where this is. Some students will draw a sketch as their final answer. Some students will put down a quadrant, like quadrant 1, 2, 3, or 4. You should do one of those two things. Draw a sketch or put down the quadrant.